everyone for joining us on our 6th IIoT India Digital Connect series on innovation in additive manufacturing using IIoT platform. My name is 𝗕𝗵𝗶𝗶𝗍 and I am your host for today. Often considered a futuristic technology, industrial 3D printing, also known as additive manufacturing, is becoming popular with manufacturers. Additive manufacturing are opening new opportunities in terms of production paradigm and manufacturing possibilities. Manufacturing lead times are being substantially reduced, new design will have a shorter time to market, and customer demand will be met more quickly. So what does the future hold for additive manufacturing? Let's find out in today's session. Join me in welcoming today's esteemed panelists. We have the great pleasure of having with us today the head of additive manufacturing, Thyssenkrupp, Mr. 𝗕𝗲𝗷𝗷. Thyssenkrupp was the first company in the world to have qualified 3D printing facility for critical marine parts. Mr. Ong and his team are active in the diagnostic, design, and development of industrial components for industries ranging from transportation to defense. He is also our moderator for today. Thank you for joining us. In the panel today, we have Mr. 𝗕𝗲𝗷𝗷, AddWorks leader, APAC GE Additive. He is responsible to accelerate additive adoption for GE's additive customer in APAC region, which encompasses additive training, consultation, design, materials, prototyping, part qualification, industrialization, production qualification, and low-rate production. Thank you for joining us today. Next on the panel is Mr. 𝗕𝗷𝗷𝗷, Managing Director, India and Southeast Asia, Stratasys. With over 18 years of experience in the technology industry, Rajiv leads Stratasys India and Southeast Asia team to drive sustainable growth of the 3D printing business in the region. Prior to this, Rajiv was a country manager at Autodesk India and SAARC. Thank you for joining us today. Joining us next on the panel is Mr. 𝗤𝗵𝗶𝗍𝗶, Head of Category APJ 3D Printing and Digital Manufacturing HP. 𝗤𝗵𝗶𝗍𝗶 has over 20 years experience in the design and manufacturing industry. 𝗤𝗵𝗶𝗍𝗶 was a part of HP's founding 3D print and digital manufacturing team based out of Singapore since July 2017. He was responsible for developing the 3D printing partner network for India, South Pacific, and Southeast Asia before moving to this current position in category team. Thank you for joining us. Finally, we have Dr. Alexander Liu, who is the head of Additive Manufacturing Program, Asia region at ASTM International. He is responsible for ASTM Additive Manufacturing Center of Excellence and various additive manufacturing programs in APAC region. In his role, he works closely with the National Additive Manufacturing Innovation Cluster, NAMIC, in Singapore. Thank you for joining us today. It is an honor to have industry veterans like all of you on the panel today. I now request our audience to take a very quick poll so that our panelists know you better and can streamline the discussion accordingly. The poll is on your screen right now. Scroll along and select the most appropriate option and do not forget to submit your poll. We have received an enormous number of queries from all of you present in the audience. Our panelists will address them during and after the discussion. You are welcome to ask more questions via Q&A function throughout. You can choose to upvote a question that has been already asked by someone else that will help us to prioritize. Any questions which remain unanswered can be posted to our IIoT India DigiCon Series interchange platform, the link to which will be provided towards the end of the session. Few people are still left to submit their poll. All right, here's a summary to the poll. So 42% of our audience use in-house 3D printer, and 47% organizations are using 3D printing for prototyping, and 62% of organizations are currently applying 3D technology. Now, without further ado, I request Mr. 𝗕𝗲𝗁𝗁 to start today's discussion. Over to you, Mr. Ong.
Thank you very much, Somali, and it's a pleasure to be here with the panelists as well as the audience. This is a great honor. I have had the pleasure of working with some of the panelists, and we are looking forward to actually sharing some of our thoughts as well as having a lively discussion today. And very glad to have you join us. We have received questions that we were looking forward to also answering. The topic today, as has been presented, is on the innovation in additive manufacturing using IIoT platforms. And that is what we will be ostensibly covering. But I think beyond that, I think we'll also be using this as a launch pad to other discussion topics around 3D printing. I think 3D printing being, by and large, the overwhelming interest and focus from the polling of the audience. So we will also use this discussion to also frame that. And maybe just as a start, and the way that we can do this is that as we were waiting for the talk to start, there was a slide there which was actually talking about the 3D printing being older than the internet. I think that was a very apt comment to be made, because I certainly, when I started 3D printing, it felt much longer, right? And at that point in time, I actually had a lot more hair. So this is definitely a case. I had hair that looked a lot like Rajiv's, very stylish, as well as Alex's haircut. I think that those are the stylish cuts that I aspire to have. And being in the industry for so long, it definitely does feel like additive manufacturing has been spoken about forever, but has always been one of the sort of a slow and steady technologies that you hear about that's reliable, but in no way, when compared to IoT, you start to hear about 250 times increase in terms of relative market share for IoT platforms. You start to hear about things like $150 billion of industrial Internet of Things spending by the year 2022. You hear about BCG surveys and reports about 50% of IoT spending on manufacturing logistics just in this year alone, in 2020, last year, right? That these are things that IoT seems to have already overtaken additive manufacturing in terms of its interests and activity levels. So I think today the discussion is around, nonetheless, that these technologies, while sexy and move forwards, we will bring the flavor of also where additive manufacturing has come, and also the time for additive manufacturing is now, right? That what we have seen in the last 2 decades is that additive manufacturing has moved from a prototyping milestone to a progressive scale-up milestone in the last 7 years, where we've seen growth in excess of 20% for additive manufacturing. And then from 2020 onwards, moving into the industrialization phase of additive manufacturing, that is definitely where the panelists, as well as myself, we see additive manufacturing. And that would be the basis for which I think a lot of our organizations have spent resources and also have garnered success in these particular areas. And the discussion today will be centered around how it is that the next evolution of additive manufacturing beyond the technical developments that are happening would be, of course, the promise of how it is that the innovation combined with IIoT platforms truly unleashing some of the novel means for which we will then sort of see Industry 4.0 really coming to the forefront. And I think that's the exciting part that we would like to get to today as well. So I think it is in this context that I'm setting up the discussion viewpoints, inviting our esteemed panelists to share their thoughts. We are very grateful for these experienced speakers as well. So by no means a pre-rehearsed regurgitation, but really an informal and hopefully novel sharing of thoughts and ideas, both amongst the panelists and also with the audience. So perhaps as a means for us to start on this as well, then would be to actually get on the same page first about what the IIoT platform means, in your opinion. And in this case, many people, I think, have different concepts of what an IoT platform means. I like to get one or two viewpoints about this as a representative stance of where the panel is at. Could I ask probably Rajiv, any thoughts on what an IoT platform is?
Hi, thanks, Ken, and pleasure to be here with the esteemed panelists and the great audience we have today. We've all been reading a lot about IoT, Industry 4.0, and the driving philosophy beyond IoT is that smart machines are not only better than humans at capturing the data in real time, they're also better at communicating important information that can be used to drive business decisions faster and more accurately. So it's actually an amalgamation of a lot of factors like sensors, actuators, softwares, middleware, all of it combined with big data and smart analytics to come up with information that is real time, that is useful, and can be used in a productive way to influence decisions, thereby reducing, let's say, things like unplanned downtime, improve productivity, and improve quality in many ways.
Thank you, thank you. I think that's a very good definition, and I think I see one of the participants in the audience had also given us a working definition. So thank you so much. And I think that it goes to show that it is about the connecting of these disparate layers, connecting from typically what we see as from manufacturing through logistics, through maybe even all the way to customer service, and all the way, originating from the design stage. That this would be the key of what we're talking about. Anyone else perhaps will want to provide their perspective on what that platform looks like or entails? Mitchell, yeah.
Hi, Ken. You mentioned customers, and I'd like to thank our customers and partners that are all on this call in India. So you're all helping contribute to this exciting forum, and many of you have your devices connected to our HP cloud system, and as a result, as Rajiv mentioned, we're getting some really important results and statistics. The reality for us as HP is that we do have millions of IoT devices, mainly consumer driven. Some of you are familiar with some of the platforms that we have, such as Instant Ink, but we also have very strong domain knowledge in digital print. And this is really where the industrial aspect comes in, where you've got very high volume telemetry data, a lot of focus on processes, and there's a lot more data being generated. And our 3D print technology falls into this category of our personalization and industrial business. And ultimately, as you pointed out, it's to improve the customer experience. This is around things like uptime of machines, yield of parts, time to fix, time to repair, these types of things. So for us, I think we have a very broad, connected platform of things, and AM certainly is able to leverage that.
Thank you so much. I think that covers and encapsulates a lot more around the customer end of this, and I'm sure that between yourself and Rajiv, we sort of cover from the design phase all the way through to adoption by customers. So then maybe jumping right into the meat of the matter, then it will be actually asking our panelists here as to how your organization or your customers are planning on adopting or have adopted additive manufacturing using the IIoT platforms. So basically, you know, the meat of the matter of what was in the title, you know, how is it currently being adopted or are planning on being adopted by yourselves or your customers? Maybe to just put some swim lanes around this. One thing that we've always said about is that when we talk about the IIoT platforms, that it basically provides you with better planning insight, right? Insight into how it is that your production is running, right? Analytics around through sensors tied into the production machines. So perhaps one way of looking at it is if you have this better planning foresight, then why do you require AM? I think this might be one work stream that I would like to pose as a question first, in the context of what we've asked. How is it that your customers are looking at this? I'm wondering if anyone would be interested in answering this. Mitchell, would that be something you could take on?
Yeah, I can expand a little bit on what I said earlier, and you know, where I think it becomes quite interesting is when we start to scaffold the additive data onto our existing platforms, we can start to incorporate some of these you know, deeper insights, and that enables us to improve the outcomes of the printed component. And you know, as was mentioned by you earlier, certainly production is something that is a driving direction for additive. And the more that we go down that path, the more critical it becomes to better understand how to improve the capabilities of certain parameters or processes to improve things like yield. And of course, yield correlates directly to forecasting, planning, availability of finished goods. And then obviously off the back of that, for us internally, to manage our own supply chains and ensuring that we have the raw materials required at our customer sites in our respective countries, so that we can ensure that our customers are well positioned and they're planning as well. So you know, I think that's one way that we start to do that through the AM platform at least.
So you're referring to that for your current fleets of printers that are deployed, that you actually do utilize that information to actually do the planning on top in terms of the material supplies to these customers?
Yeah, we'll often work with our customers as well, you know, to validate if they have an upcoming demand. You know, actually we have a fantastic story in India just, you know, 6 months ago with some PPE developments. We had a huge increase in demand for components being printed on our products, and I'm sure many of our panelists saw a similar surge. And it was really important for us to understand, you know, where our partners and our customers needed those consumables, and we were able to make decisions about how to allocate resources in the instance they could have been limited. This includes not only materials, as you mentioned, but you know, engineering resources, certainly the software and backend that we're paying a lot of effort towards and attention to ensure that the machines are able to perform in these peaks that can, and sometimes in that instance, maybe we're not as anticipated as we would like.
Wow. Yeah, that definitely sounds quite good. Nothing I expected, no less from HP, I guess would be the way to put it. Anyone else with regards to planning foresight, issue of planning foresight and work stream, how that helps for your customers or your organization?
Can I add if?
Yeah, sure. Go ahead, Rajiv.
So yeah, from a equipment manufacturer's perspective, to your first question, when we have traditional tools, why we need, so I mean, traditional and additive will continue. It's a new way, a different way. There are certain advantages, certain challenges, but having gone through that argument, now the next step is how do we make our equipment access exactly the same or even better than all the traditional tools of manufacturing that exist today. So at the heart of IoT is data and connectivity. So for 3D printers to become an integral part of the shop floor, companies like us are planning to make data accessible to the consumers. So they have lots of systems running in-house. These are PLM, these are ERP systems, these are MES systems. So what Stratasys is now offering is a software development kit, which has application programming interfaces that enable the customers to connect their data sets into the existing production flow, thereby giving all the valuable information that is needed for smart analytics to take decisions. So thereby making additive manufacturing also a real part of the factory floor.
Well, so this is it's almost a discrete, could I sort of describe it as an extension of, I think what we know Stratasys for in the AM world, that this is in a sort of encapsulation of all of this disparate data streams that have to come in order for you to sort of take that information and utilize it for AM purposes. Would that be a right way to put it?
That's right, Ken. That's the right way to put it.
Rajiv, I have a question for you. So when you mentioned the software kit, do you allow, is it a one-way communication? Do you allow to extract data and also write data onto Stratasys machine?
Yeah, we are working on establishing a two-way connectivity through APIs. And then we have our standard partners who enable this implementation service. So to your question, it will be a two-way connectivity.
Nice, thank you.
Which I think in this case is also emblematic of a sort of a closed loop IIoT platform, right? Which is that it is actually such that you are able to respond from the analytics and the data stream that you are getting. You're able to respond to that, and I think that this is a perfect example of how this can be done.
Absolutely.
Any examples that you can give with regards to implementations that are already happening or are in the planning stages, for as an example of what you've described in the kit?
So we have one use case that that we worked with a company called Honda Cars. Honda is a very well-known name to everyone.
I've never heard of them.
Sorry. So our journey on additive manufacturing started in a very standard way with them. It was not about IoT. It was about how we can actually pick up some of the workload and make additive manufacturing a part of their production processes. So the idea was to have some smart jigs and fixtures on the shop floor. And when they started manufacturing these jigs and fixtures, they got the usual benefits of additive manufacturing, which is about 70% reduction in weight because we shifted from metal to plastics, considerable reduction in cost, considerable reductions in time. So that was one stage of the process when they integrated additive manufacturing in their production process. So when they got accustomed to using additive, they went a step ahead, thinking that how we can actually leverage this further into their issues that they were facing on the shop floor, some of them with quality. So one of the examples that they shared with us recently was about the fixing of windshield on the weld body of the car. I'm not sure how I can explain you without pictures, but imagine a car coming out of the weld line, body in white, and you have to put a entire windshield, which is 1 meter by half a meter product with the right tolerances and with a sealer. Now the sealer is also unique because you put the sealer, you put the windshield, and in some time the sealer becomes rubber and it's a permanent fix. And while fixing it, you have to maintain the right tolerances as well as the height of the sealer. And to kind of measure it while it is being fixed, Honda manufacturing engineers made a very smart assembly location jig. It was very complicated three-dimensional tool. You can imagine the surface of the car, A pillar, B pillar, all those complex profiles, and then you have to measure three-dimensional tolerances, X, Y, Z. And with traditional manufacturing, they were finding it very hard to manufacture some tool like that. And by virtue of the freedom of design that additive offers, they were able to print this. And while the windshield is being fixed on the car, in real time, they are able to get the data on whether it is being fixed correctly or not, and take a corrective measure on the moving line itself, then waiting at the Q-check end, where the sealant has become stiff, it's become rubber, and you have to actually cut out and waste that windshield that was fixed. So this is a live example that one of our customers used, putting a sensor in the assembly location jig using the real-time data for correction, integrating with SCADA. So if there is error, it raises an alarm, and on the moving line, they make corrections as against doing it at the end of the line.
Well, yeah, thank you. That's a very a compelling example of the IIoT platform in operation. I wanted to perhaps also ask the giant in the room, which is the GE. Then, what has been your experience into this integration process?
Thanks, 𝗕𝗵𝗏. Recently, I think in 2019, Formnext or sometime, GE Additive launched a product called Build Performance Analyzer. So which actually gathers all the information from the sensors what have been put into the 3D printers, these metal 3D printers, and gathers the real-time data. There is like thousands or more than thousands of data points we gather, and using this, you can the manufacturer can actually make a very informed decision. So one of our customer who is into the implant business, they do produce more than 25 different implants. All these implants are in serial production, not in prototyping anymore. They use our RCAM or EBM technology, and they have produced more than 16,000 serial parts using implementing the BPA. The BPA or Build Performance Analyzer. So Build Performance Analyzer, what it does is it in real time, it captures the defects in the product or the part, and kind of tags it, saying that, okay, this is where the defective part could be. And hence, I mean, they can identify and reduce a lot of inspection costs and things like that. So that is a very good example from our customer side. We have even published this story in public. The customer name is ImplantCast, and they have very effectively used the BPA and the IIoT platform to enhance their production and to increase their productivity.
Wow, that's great to hear. I think that for implants, this is a high value items. Definitely, I think what we see in aerospace, of course, in automotive, in medical, that we typically see the adoption of these new technologies much faster. I think what you have both shared, both gentlemen, is the combination of AM and an IoT coming together for this particular purpose. Any other, so what about this combination of AM with the IoT platform? What is it that makes it so compelling, do you think? I mean, so far, you know, there are buzzwords that you see for any of the audience or for folks who are not in this field. There are simple buzzwords, but what is it about this two technologies coming together that's so compelling? Maybe I can throw this out again to Rajiv.
I'm the chosen one today. So, in my view, the compelling nature of additive has been there for a long time, and since Industry 4.0 is becoming the norm today, it's a given that additive has to follow the norm and become a part of the overall workflow, which means we as manufacturers and on the other side, consumers need to extract all the data in real time from the production that happens through manufacturing. And by the way, manufacturing with additive, mass manufacturing with additive is becoming real now. It's not that you will either do this or you will do that. So people are doing both in conjunction very well. And there are cases where thousands of parts are being only produced by additive manufacturing and not by the traditional ways of manufacturing. So the idea is how accessible, how friendly you can make the information from the additive manufacturing onto your existing workflows, so that the same data sets can be utilized for better planning, better forecasting, quality control, etc.
Okay, that sounds very compelling. Alex, how about bringing in for this? What do you think? What's the magic combination of these two together?
Yep, I would think that eventually, from the standards development organization point of view, when AM meets IoT platform, we will need standards. So we started developing standards for additive manufacturing since 2009. And today we have only about 25 standards that are being published. In the last 2 years, we accelerated this progress, and we have now about 65 in development. And these are all on additive. But the key takeaway here is that along the activities for standards development in additive, we established new committee that is working on data management as well as possibly cybersecurity and IoT. So we see that the next in a way, in order to elevate additive manufacturing to the next level, we are looking at the convergence of emerging technologies such as IoT, cybersecurity, robotics. So with the arrival of 𝗕𝗏𝗿, all these come into play and gel very nicely, working towards advanced manufacturing. So, and this is important for AM because additive manufacturing itself is the cornerstone for advanced manufacturing. So this is where we see this moving forward in the future. Okay, so it's almost a preemptive strike from the standards organization standpoint. That's right. Okay. I think I see Mitchell trying to having some thoughts over there.
Yeah, I think Alex raised some good points, right? Especially around data management and data security, and where I see it as a nice fit between these two emerging technologies is around this unique position that additive has in converting digital to physical goods, and it's somewhat specialized in this way compared to traditional manufacturing technologies. And as a result, those digital informations become even more critical for AM, and it means that things like Alex mentioned, cybersecurity become increasingly important because it's no longer a fairly generic piece of code, perhaps, or fairly standardized machine operating process, but it could be fully resolved design of a given good or product. And this is where, for us in HP, obviously we have a very strong history in cybersecurity stemming from our PCs and our traditional 2D prints. And we've recently set up and in the process of establishing our own security advisory board, bringing in a number of outside experts to help understand, some of the challenges involved in cybersecurity. And a lot of our products have built-in security features to help restrict any malicious efforts in and around data management. So I think in this way, 3D is bringing these two really important components together. And I think it has a lot of opportunities and a handful of risks that Alex and his team sound like they're busy reducing. So great to hear that.
Yeah, definitely. I think that you're starting to bring the discussion a bit down to, what are some of the risks that are inherent in this. And I think that that's definitely a path that we want to follow and have the experts here share a little bit about that. But before you do that, perhaps just a final point about the compelling nature of the combination of IoT to AM. And from at least a Thyssenkrupp standpoint, this is also something that we definitely agree that this combination is very powerful. And as 𝗕𝗏𝗿 had mentioned, that we are one of the first movers in terms of getting the certified facilities such that we are able to fabricate parts. And that we work with both maritime sectors, with defense sectors, automotive sectors, in the fabrication of parts using 3D printing, and that by being able to have that digital thread connect from the design phase all the way through to customer adoption, and in fact having that information. Because for the nature of our business and our customer engagement relationship doesn't end when that product rolls off the floor or gets taken or sold at the showroom. That there's a sustenance period that goes on for much longer than that. And I think that for 𝗕𝗏𝗷𝗷, that's also probably something that you see similar with Mitchell, and that in these types of a relationship, that good business is a sustainable business. That's business that allows for the customer to maintain a relationship with the producer of the part and of the design. And I think that this is the means for which AM has integrated into IIoT, in our opinion, and where we see a lot of the upside here is that this closed feedback loop will enable us to actually theoretically, right, you can even go all the way autonomously to the redesign or design optimization of that part, such that at the production stage, you immediately capture the benefits and you capture the feedback from the customers. And I think this is where we sit, that we can see that it's coming, and that having a human in the loop is definitely something that we are currently implementing. But going forwards, that from a future crystal ball standpoint, this is definitely something that we see. And I think that probably resonates with a lot of the audience, as well as with the panelists over here. So I look forward to questions around this later on when we open to the floor in about 10 minutes or so. Where I think now Mitchell has sort of opened the way for us, which is to explore a little bit of the dark underside of the IIoT platform in AM. Then is essentially looking at any risks. Right, I think he's also opened up the path to cybersecurity, talking about network redundancy. Any other risks that you gentlemen, the panelists, have you experienced or would like to point out?
I think just one other extension on what I mentioned, Ken, is a lot of our customers in these highly regulated industries are operating in a very unique situation where connectivity is not always available, and that in many ways limits what IIoT can offer to our customers, because we cannot necessarily leverage a lot of our cloud intelligence and our systems that would typically help to do some of that analysis. And this is another area where we can start to look at our partners in other HP enterprise, for example, who offer server facilities and set up a standalone site where they are not necessarily connected, they are offline, but we can still start to leverage some of the tools in a self-contained environment. So I think that's another area that a lot of our customers in those regulated industries would be facing those types of challenges.
Yeah. Do you see that? Yeah. Sorry, Th, go ahead.
I totally agree with Mitchell. One of the thing is the IP concerns. Like there is a part manufacturer and then there is a design owner or the part owner. And what happens when the IIoT context is you are sharing or capturing a lot of information. So first thing, first and foremost is what to capture, to what extent to capture, and what IP you are exposing to the network. And like Mitchell told, I think more and more there will be the server will be residing in the company rather than residing in the cloud platform kind of a thing. So IP concern is another biggest risk when it comes to taking a additive full-fledged on the IIoT platform, I would say.
Oh, so you mentioned a point. So you're saying that the server would be residing within the organization. So you're saying more cloud-based, as
cloud-based, yeah,
specific to the storing of IP design, basically design IP. That might be.
That's correct.
Not so conducive, and that organizations are moving away from that. Is that your point?
That's correct. Yeah.
Wow. Yeah. I think that we definitely second you on that. That's also something that is foremost on our discussion and our consideration as we deal with IP. And as part of our business model, Thyssenkrupp actually works with third-party design owners. So basically OEM of components, and that to basically alleviate the risk of data leaks. You really have to assure your customers that this is something that is being addressed, that first and foremost, not having it be on unsecured networks is definitely a big thing. But I think in the context of additive manufacturing, I think there are two aspects over here. One is the treatment and and flow of digital design data. And then second, which is I think something that is being addressed from a cybersecurity standpoint. How do you actually secure your networks and your servers, and having the right authentication protocols and access controls. But on the other side of additive manufacturing is when your build file is being sent to a printer, and having that be printed, if that is something that is being done at a remote location, how do you now ensure that that build file is something that is not hijacked or is not copied and saved for another day? I think that that's something that was actually so important that it was brought up in the World Economic Forum several years ago when they spoke about cross-border digital manufacturing, right? And so I think at that point, a lot of us looked at that and thought it was science fiction, but I think it's really coming true. But I'm wondering, does GE have any safeguards against this, given that you're probably manufacturing in different sites and locales? How do you manage this part about the injection of build files into machines?
So right now, the build files, like you mentioned, we are not. There is no network which is like established, and we are firing the print from a remote location. That is not happening today. So the build files are generated in one location and safely transported or transmitted to the another location through the safer portals, and then the execution happens. The true integration of IIoT has not happened, I would say. Till this point of time. I mean, that is probably a few months or few years away, but that is not where we are as of now. Like, okay, entire thing is on a remote, network, and I can fire on a remote a printer sitting in one side to another side. I think that is not yet there.
Got it.
Yeah.
Rajiv, any thoughts about this? I think from a software perspective, I'm sure these are pain points that you've heard of, but is Stratasys developing anything that addresses these thoughts?
So there've been some discussions about how, let's say, an OEM or a large aerospace company could license someone to kind of manufacture just the part that they need as a spare part or an inventory, but nothing here and now, I would say. So it's in the works, but this is a common challenge that all of us face. And efforts are on to see what best can be done to address. And they sound typical to additive, but they're not very different from the standard challenges that people will face on IP about the conventional ways of manufacturing. But it's an important way, because here you can just transfer a file over the net, and then how do you make sure that only one part gets manufactured and not 100? So that's in the works, right?
Yeah, and do you think smart contracts would be the way to lock this down? Is that one path that we can take? DRM rights through smart contract management?
Possible. I mean, this is one of the possibilities, I think. But then the legalities, the software and parts, and how it would work is something which is not something that I fully understand right now.
Well, maybe from the standard side of the picture, and that could be they could pave the way. Any thoughts about this, Alex?
Yeah. So just a couple of months ago, ASTM established, or rather, we officiate the establishment of our 𝗕𝗷𝗷𝗷 committee that is specific on AM data management and schema. So on that, we look at how AM data is being managed, transmitted, and also protected, and also what kind of data representation that should be used for additive manufacturing. And this topic also goes into cybersecurity. So basically, they are very linked. So in terms of standards point of view, yes, we are developing standards for AM data representation as well as management. And we think that this is really important, and a lot of our standards development activities are actually driven by the industry. So this actually gives an indication that this demand is actually coming from the industry.
Very good to know. Very good to know. I guess if there's no industry questions, then that's not the industry to be playing in. Speaking of then about certification, what is the role of certification, you think, for additive manufacturing? And what is the current best practice? Perhaps this question I would open it to maybe the practitioners a little bit more. Perhaps I can pose this to Yataraj at this point.
Yeah, sure. Thanks, Ken. So certification is a very important and very deep topic when it comes to production, right? Metal additive production. So there are three aspects in certification, or rather in the production, I would say. So quality of the component, repeatability of the manufacturing process itself, and productivity of the overall process, not just additive, the end-to-end process, I would say. So these are the three key aspects of any production, not just additive manufacturing. So I would again come back to in-situ monitoring. In-situ monitoring definitely plays a great role in all three aspects of production. So for those who are hearing in-situ term for the first time, it simply means on-site. That's all. In-situ is on-site. And in-situ monitoring so means observing and recording data while the printing process is actually happening. And additive technology is very, very digital in nature. I mean, you have digital files and I mean, quite digital in that sense. And even the metal additive machines that we have today, there is a great amount of sensors we have already built into the machine. And there are a lot of things which can be integrated even after we buy the machine and put it in the shop floor. And all these sensors generate tons of data like melt pool temperature, melt pool size, laser power, layer thickness, quality of powder, recoating, oxygen levels or vacuum levels in the printing environment, and so on, right? So using all this data, we can actually build analytical models to understand the quality of the additively manufactured component. And the data recording, analysis, and prediction can happen almost in real time nowadays. And this data and models can tell us about, one, the quality of the component, whether it is good or bad. And if it is bad, where exactly it is bad and what is the nature of the defect. So based on this information, manufacturer of the part can actually decide whether to accept the part or totally discard it or scrap it, right? So the in-situ monitoring or in-situ data, let me say in-situ data, also provides a unique ability to optimize the production process itself. And the in-depth insights provided by the data helps the manufacturer to understand, one, part-to-part variations in the same build. If there are like 10 parts, how the quality is varying from part to part, and between the builds, build to build variations, and machine to machine. If you have a fleet of machine to machine variations, part to part, build to build, and machine to machine. All these variations can be understood very well. And all this helps you to make the production understand the production process capability and ability to identify where exactly are the hidden problems or hidden factories, and then how to address them to make the production process more efficient from repeatability and productivity point of view. And another thing, how the in-situ can help you reduce the cost of the component is, so typically if you see the value chain of the part manufacturing, the 2/3 of the component cost, at least in metal additive manufacturing, 2/3 of the component cost is added after the 3D printing. Like for example, you have to do stress relief, part removal, or heat treatment, finish machining, surface finishing, inspection. All these actually add or cost to the 2/3 of the component cost itself. And the defects, whatever, if at all, if they are there, are typically identified at the final stage. So think about identifying the defect early on in the process and eliminating that particular part, rather than adding all the cost to the part and then actually discarding it, right? So that is another way you can actually reduce the part cost by properly implementing the in-situ monitoring over, of course, IIoT kind of a platform. So if the manufacturer has the ability to flag or identify the defective component, he does not have to subject the defective component to all the processes, which I mentioned earlier, right? So by doing so, overall manufacturing cost itself can be further reduced. So IIoT and additive and enabling, and by leveraging in situ monitoring can definitely accelerate the certification process and greatly enable the production, which is seen as a challenge to most of the companies on how do I actually productionize additive manufacturing, or is it only good for prototyping kind of a thing. So that would be my take on the certification using IoT.
Thank you very much. I think that really is very comprehensive what you've just said, and I'm sure there are a lot of questions from the audience around this. So we can address that. I want to make sure we spend enough time for the audience to ask their questions. But maybe a very quick one here. You've mentioned it's analytics, and what do you feel about the role of AI in contrast to analytics? Do you see AI having a potential in replacing this?
So absolutely. So wherever data is there, you cannot, it cannot be the case that you will not hear AI. Whenever the data is there, you will obviously hear AI. So the first and foremost thing is you need data. You need to capture the information to build these models, and then the artificial intelligence. So we have started doing that through enabling our sensors to capture data and the softwares to record the data, and to and the softwares to build those analytical models and things like that. And natural extension of this would be definitely AI, where you will be able to analyze the data, take the machine driven or the algorithm driven decisions to either take some action in the real time in a feedback kind of a thing, or at least in the almost near time, where you can at least have a ability to stop a build, or stop a or discard a part, or things like that. So I wouldn't say AI is not relevant. AI would be definitely relevant, and that would be a natural extension of the topic what we are discussing here.
So in order to do that, I need to be a computational, mechanical, electrical engineer specialist.
No, you will have the team. You will just have to be a data analyst for that, or a data scientist, I would say.
Thanks
The
so much.
mechanical, electrical, and all will come.
All right, I think we have. I'd like to move us now to more of the audience side of the session. Maybe starting with some questions that we have received, and then opening it for the live Q&A. So some of the earlier questions that we've gotten, the first question is, do you think as 3D printing industry will grow, we will face new design challenges for the same products we used earlier? I'll repeat that question. Do you think as 3D printing industry grows, we will face new design challenges for the same products we have used earlier?
Go ahead with this, Ken?
Yeah, please, Rajiv.
It's a very interesting question, because innovation never stops, and with the flexibility and the design freedom that additive manufacturing provides, the designers will always push the limits of innovation. So I think it'll become a culmination of various factors. So one, we start with design freedom. So you design anything without worrying about how it can be manufactured or how it will be manufactured. So there's no constraint. Then comes a factor of part consolidation. So can I make this 20-part assembly into just single component? And there are hundreds of use cases each one of us would have experienced during our additive manufacturing journeys, that part consolidation is here and now. So how you can make from, let's say, 20 assembly to one, from 100 to one, and so on. And it's a process that goes on. Then comes that, can I make my part multifunctional? So while I'm designing an antenna, can I put some integrated circuitry in it? So that extends it one step further. And while I'm putting some circuitry, can I also use this antenna as a stiffener for a bracket and remove that part which was already there? So that gives it another extension. And then comes the design for additive manufacturing, where there are multiple tools and softwares available today that will help you optimize the part, make it lighter, yet stronger, make it aerodynamic, make it more acoustic friendly. So these are all the tools which will actually become an ecosystem and drive the next phase of design in this new domain. It's not just about additive, but how the overall ecosystem will work together to work at a system level design than people mostly thinking about a component level.
Very, very interesting.
Yeah, I think it's a really good point actually that Rajiv raises. It's this system integration and this concept of the broader ecosystem that everyone is operating in. And I think, you know, the biggest design challenge I see a lot of our customers facing is how can we add more value into an additive product? And there were some great examples there from Rajiv incorporating, you know, different components into one, you know, bringing other components that were typically separate into the same assembly or component. And this is really where additive has an opportunity to participate and add more value than traditional manufacturing technologies. Of course, it has its own challenges as well. And, you know, often people are working within a bounding box that the machines will operate in. You know, obviously, you know, all the work that GE have done and mentioned by 𝗕𝗷𝗷𝗷 around thermal management, you know, these are all design constraints as well. And at the end of the day, for us, it's how can you add more value with this technology compared to traditional technology?
Yeah, totally agree. Totally agree. And I think that for the design constraints, I think definitely for the high value parts, that's something that you really have to consider from a total cost of ownership perspective, and also the challenge. And I think that actually speaks to one of the persistent questions that have been coming up in the audience is around wire arc additive manufacturing, and what is the challenges faced, and what do we think is the future of wire arc additive manufacturing? Perhaps I can ask Alex.
Yeah, I think this is one of the more interesting questions because from ASTM point of view, in the past 2 years, we have seen an increased number of requests to develop standards that are specific to DED and wire arc. And that is because it appears that everyone is now very comfortable printing parts that are of this size, you know, and then they want to go something bigger. So to go something bigger, they look at the process and say that, okay, maybe wire arc is the next choice because North Titanium has a certified structural component that is flying right now. So then they are looking at wire arc. But along with wire arc, there are just so many challenges that is not shared publicly, right? So I give you an example that I've seen a company that printed a really huge part, and it is probably 80% near net shape, and you got to go through machining. Then for such a huge part, you need to go through, you need to have a huge CNC machine to machine it down. And you can only machine it to maybe 95%, and you got to do heat treatment, right? So you got to have a super huge furnace to heat treat that super large part. But with such a large part, any heat treatment, thermal treatment, the part will get distorted. So then they got to manufacture clamps, the positive and negative clamps to clamp the whole thing, middle, end, and the portion, clamp it down, and then put it into the furnace and take it out for, after heat treatment, take it out, then you machine down. So you realize that there are just so many challenges involved in wire arc that I mean, in general, people see that having a wire arc process is good to print huge parts, but after that, they realize that there are just so many challenges that they face. Then the next logical step would be then, is there a standardized guideline? So then they go to ASTM, hey, how is other people doing? And is there a guideline that we can follow in order to meet certain requirements and fulfill certain requirements? So I think this is a very exciting field, I think, at least for the next few years on 3D printing or large parts, metal large parts. Yeah.
Yeah, I think very doesn't leave anything to the imagination. I think that sounds like a hamster on a giant hamster wheel.
Okay, I'm curious, Alex. Sorry, quick question from me. I think it's a really great example, and often what we'll find is, you know, this customer that you have, obviously they've developed a lot of IP in coming up with these processes and capabilities. And how does ASTM, you know, flesh out some of this IP? You know, because I think that's a real challenge. There's a lot of knowledge and capability, but it's not openly shared all the time.
Yeah, I think this is a good question. So ASTM provides the platform and the infrastructure to let the community come in to jointly develop standards together. And one of the key, when they develop a work item and before publication, they have to relinquish certain degree of IP so that people can then adopt it because it's a public document. And most of the time we may hit a roadblock because some of these IP are so sensitive to them that they are not sharing. But on the other hand, in terms of certification, to develop a certification program, you need to rely on standards. But if there is no standards that's being developed, they cannot develop a certification program to certify your part. So then they would then, in a way, people who participate in standards activities have a certain agenda to say that they can they can proudly say that they developed this standard was developed out of the process and procedure that they have developed in-house, and it is now a standard guideline. So then this also becomes a selling point or a marketing content for this company to sell their products and services. So I guess right now ASTM has been we have been managing this pretty well. That to achieve a certain degree of advancement, there must be some level of IP to share with the community. So this is what we are also advocating.
All right. Yeah. You need to have some. You have to provide some data, and then you can sort of get some benefit in return.
Yep.
Okay, I'd like to ask one of the questions from Ashwin Ramesh, which is what are the challenges faced by you when positioning an Industry 4.0 or IIoT product to a customer in a market like India? Is it easily accepted by customers? So for the panelists, if you can turn to the question and answer, you probably see that as well. So what are challenges faced by you in positioning an Industry 4.0 product to a customer in a market like India? Anyone else who would like to answer this question?
I'll have a quick go at it. I think where India is, in my mind, so capable and so innovative is coming up with these novel approaches to fixing problems. The classic 𝗕𝗷𝗷𝗷 is the term that I have been told. And in my mind, this is one of the most exciting parts of Indian innovation. What goes with that, and this is where I see the challenge, is in a way, by moving down the Industry 4.0, you have to regulate and you have to put everything into a very narrow process window and process parameters. And in some ways that can stifle the creativity in a market like India. In saying that, India has such a fantastic IT infrastructure that there is a really unique opportunity, I think, to bring Industry 4 into India and really have an opportunity to build where some other countries probably have not got such a strong IT infrastructure, particularly around Southeast Asia, even certain parts of China. I think India has a really key advantage in some cases as well.
Yep, I think Rajiv, any more thoughts about that?
Yeah, and also, India is now at a place where we are having a move towards manufacturing with additive. Still so far, it was still in the prototyping stage. People were really not making it a part of their mainstream applications. So once this thought process of additive being a great tool for having your production processes to be mapped on, it will then become integral with Industry 4.0. Till so far, people kept it as a separate entity in their design houses. Now towards the move to manufacturing, this becomes an integral part of the Industry 4.0 story.
Great. Okay, I have another question, and panelists, feel free to look at the questions and identify the ones that you also like to address, if you think ones that pop up at you. This is from 𝗤𝗵𝗶𝗽, which is how can you incorporate or integrate current manufacturing process to fully IoT control system without changing the whole automated machine equipment? Is there ways current that we can read sensor signals and directly influence the output actuation to fully monitor and control process manufacturing product?
We have some experience on some older lines in HP. I think this is what the question is about. it's more integrating into an older system, perhaps, that doesn't have all of the connectivity. I think I'm reading this correctly. And we've got some good examples of, bringing some of these more operational technologies into older lines through bringing in a third-party sensor or monitoring devices to then feed back into some kind of dashboard, or where required, some actuators to help I guess improve the visibility and the amount of data that we can collect from older production lines.
Yeah, and I think that's to supplement to that. I am also in touch with there are multiple third-party suppliers that are basically making a business where they're able to connect legacy or existing systems to the IIoT platform. So I think the idea being that the IIoT platform is the single point of unification of data, and that regardless of whether there are machines on the production line floor, or your design software, or your supply chain down stream, that there are multiple different types of IoT sensors that could be purchased, acquired, and integrated to get that contiguous flow. Okay, next.
And just to add that, with companies like ours, we are providing the software development kits and APIs to enable these third-party vendors to set up the two-way connectivity with the existing or the legacy systems that you may have.
Okay, great. Now just turn the question more on the AM side. We have a question from 𝗕𝗲𝗏𝗃𝗷, which is, with design freedom, can you elaborate on the new challenges on multi-material improved design at the system level? Alex, I don't know whether you might be able to take this, or 𝗕𝗏𝗷𝗷.
Yeah, so the multi-material, is he referring to polymer or metal? I would think that would be a very different set of challenges. But I think
metals, yeah.
Metals, okay. But I think what's more important is that when we look at design, today we look at existing components, and then we try to replicate the same design by using additive. And then when we look at designing new components, then we are looking at new product introduction, NPI. And a lot of times NPI would then lie in the ODM, the original design manufacturers, or OEMs, where they own the designs. They are able to introduce additive design into their new products. So I'm just thinking aloud, how can we then have less restrictions where more SMEs can come in to participate in the design freedom kind of for additive? Because right now I would see that a lot of product owners are MNCs, and big companies are the ones that own the design. So how can we then allow SMEs to come in and participate in this area?
So answering on the multi-material aspect itself, so there are definitely the DED kind of technologies which can enable it, but there are inherent limitations, like for example, in the powder bed fusion kind of technologies, where the multi-material would require two different builds and build setups and things like that. So yes, it is a good research topic. I mean, and like Alex mentioned, I mean, I think first we have to say, are we just bringing together the parts and hence we are asking for the multi-material, or if it is driving some functionality? And if it is driving some functionality, I think then if there is a business case, good business case for the organization, then it could be taken up. But there are some technologies which can enable, but some would have limitations by the nature of the process itself.
Very nice, very nice. And I think that this maybe lets us pivot to maybe a more operational, which is from Roshan Chandra. How can IIoT be leveraged to 3D print hip and knee implants using RCAM EBM? I think this is I mean, we're zooming in, and maybe we can use that as a case study of how can we use IIoT for 3D printing of hip and knee implants.
Are you there?
Yeah, I'm here. Anyone would like to take a stab at this?
Yeah, maybe I can have a go at this. So basically, according to ISO 13485 medical device standard, they will look at process repeatability and consistency. And right now in the work instruction documents in some of the manufacturing plants that we have seen, using RCAM, they do not specifically mention the process parameters or what is whether the equipment is performing optimally. So what they do is they just rely on the latest maintenance schedule that they have done. Every 6 months they do a maintenance and they just rely on that maintenance. However, 3 months after the maintenance, there may be some deviation. So then IIoT can play a role here where they can consistently and constantly retrieve data in the process to even offer more data to show that the process is consistent, the process is repeatable. And this actually gives a higher level of confidence to the customers who's receiving the product at the end. But one key thing that the industry is always very wary of is the cost involved in implementing such a solution. Yes, it's good, but is it something that is overkilling? And is the cost something that the industry will accept? So this again, opens up a new, more questions to see whether is this something that they want to go forward with.
Thanks for that. I think that's a good, perfect ending for us in terms of the question. Just wanted to quickly check with 𝗕𝗵𝗍 as to the time that we have left for the panel session. How are we on time?
Sorry, 𝗕𝗵𝗍, I had to, my internet gave away. I mean.
No worries.
Thank you, Mr. 𝗕𝗵𝗍. I think we are almost, the time is ending for us. So if you could do the final wrap up.
Yeah. Okay. How much? 5 minutes? Do we have 5 minutes or 3 minutes?
Sure.
Okay. I think that, and so thank you very much to the esteemed panelists. I think it was a fantastic session. And also I wanted to thank all the audience. We have a whole host of questions. My apologies in advance that we're not able to get to all of the questions, but rest assured that we have been trying our best to ensure that we've been able to speak to the ones that which at least we are knowledgeable about. And so them having questions around specific implementations or techniques and that might have been out of our scope or our knowledge base. So that's hopefully something that you will forgive us for. And I appreciate the time and the effort that have been spent by the panelists on this. I think where we wanted to leave you with on is that we are on the cusp of Industry 4.0. I think we do see different technologies now having a broad and rapid adoption. We do see the path ahead in additive manufacturing. Relative stalwart, although not embraced in all industries, is here to stay and will be making its presence known going forwards as well. This is a steady and stable future, and that if any of you are contemplating a future for additive manufacturing, do that, do AI, and then the sky's the limit. So thank you again for the session over here. Hand over to 𝗕𝗵𝗍 again.
Thank you, panelists, for taking out time to share your experience and learnings. It has been an insightful session. I request the audience to take a moment to complete the poll to provide feedback on today's session and share your ideas for future ones. Your feedback is extremely important to us to bring more and more such session to you. Details on joining the Interchange platform for deeper discussion will soon be on your screens and will also be a part of the email that you receive after this session. I encourage you to join and engage with the like-minded community. Look out for details on upcoming session on our IIoT India website and social media pages. Do not forget to join our interchange community for continuing the conversations and dialogues spinning off today's sessions. Once again, thank you for joining us, and we hope you found it useful. We look forward to seeing you in interchange after this session and having you at our future session. Do not forget to submit your poll. Take care and have a good day.